All right, welcome to another fun-filled episode of Research Methods number 1. We are talking about Chapter 9 now. We are entering in what is, in my mind, one of the more complicated chapters, although I don't know if you may not agree with that. I think some people tend to think that the chapters about validity and reliability, and they might be the hardest. But for me, especially once you start making your own research and doing your own, creating your own research designs and analyzing it, factorial designs are where it gets a little bit complicated. So this video is going to be longer than the last chapter. The last chapter very, very short. This one might clock in a little bit over an hour. Even though I think that the chapter on this in the textbook is not super long, I think I'm going to try to flesh out some examples for you. So let's get into it. And like always, I have a surprise for you at the end. Okay, so let's talk about the agenda. So what are we doing in this video? We're going to be looking at what factorial designs are, which are going to be when we use multiple independent variables or when we use multiple levels of one independent variable. So essentially, we are either testing something that has more than two groups, or we are doing something beyond just a simple pre-post test design. Maybe we're doing like a pre-test, a midterm, and a post-test, right? That gives you 3 levels of a variable, or 3 conditions. And so we're going to be exploring what happens whenever you decide to do that. We're going to look at a couple of examples of that, and then we're going to talk about interactions versus main effects, which is an idea that's going to come back, like many of these will, whenever you take stats for psychologists, Psych 308. Okay, so so far, a lot of the examples we've talked about have been simple experiments, which is to say they have one independent variable and one dependent variable. But that is not the only kind of study that you might do. Whenever you go into Research Methods 2 and you start brainstorming with your group and you start thinking about all these new plans that you would like to try, you might come up with something like, hey, we want 2 groups, one group that's freshmen and then one group that are seniors, and then we want to play either classical music while they study or play lo-fi hip-hop beats while they study, and then we want to see what happens to their test outcomes. So that doesn't sound like a super tough experimental design, right? But what we're doing is we created 2 groups, right? And then within those 2 groups, there's going to be 2 separate conditions. One condition where they listen to classical music, one condition where they listen to lo-fi hip-hop beats. And so that is going to give us 2 groups and 2 levels of an independent variable. So essentially we have 2 independent variables, one that has multiple layers to it. So it's kind of a complicated experimental design whenever you think about it. So this chapter is dedicated to what happens whenever you decide to do that. So simple experiments, one independent variable, one dependent variable, but that's not the only way to do this. There's ways we can make it more complex if we want to. I almost called it more complicated, but it doesn't have to be complicated, but it is a little bit more complex whenever we add more than one independent variable. Because the nice thing about, and this is going to be a recurring theme, especially for the very end of this chapter, the thing about experimental variables is that it's very easy to discern causality. So whether or not your independent variable directly affects your dependent variable is much harder to do that within a factorial design whenever you're not exactly sure which independent variable or which level of an independent variable is affecting your data. So let's get into it. Let's go through an example of driving ability. So we want to know whether or not drivers that are young are better at than drivers that are old when it comes to driving with cell phones. So in this particular example, and this is based on a real study, we have participants that are grouped based on their age. So this is kind of a non-interactive independent variable, right? Because we can't really assign people to old or young groups. And then half in that group we're going to give cell phones to use, and the other half we're not going to give them cell phones to use while they're driving. We're going to put them in a driving simulator. If you haven't seen one of these used in research, we don't have one here at Westfield, but in research you can find like these really complex like kind of cabinets that you sit in, and you got a steering wheel, and you have like this huge monitor that wraps all the way around your field of view, so it feels like you're driving. So in a driving simulator like that, we're going to have participants following a car, and that's what we tell them. We want you to just follow this car as closely as you can without crashing into them, and this car is going to randomly slam on brakes, so you have to watch out for that. So the idea is, if somebody's a good driver, then they should be able to follow closely but responsively. In other words, that they're going to follow close, but they're going to stop whenever they need to stop and slow down when they need to slow down. And then we're going to have people who are old and young, and then people within each of those groups. Some have a cell phone, some don't have a cell phone, and we're going to see how closely can they follow that car, or what the reaction times are whenever they hit the brakes. So those were the two independent variables, the age and then the cell phone. The outcome variable in this case, so how well did participants drive? Basically, they were just looking at brake time. They were looking at how quickly can they hit the brakes whenever the car in front of them slams on brakes. So this is a quick kind of visual breakdown of it, where we have two levels here, and then we have two groups here, and that gives us what we are going to call a 2x2 matrix. So a 2x2 experimental design, or 2x2 factorial design. So you're going to see this on the quiz that I made, that it can be helpful to kind of diagram these things out. If you know that you're going to be breaking things up into groups, go ahead and start drawing. All right, we got two groups, so we're going to say that this is going to be old versus young. And then whenever I tell you that each of those is going to be getting their own, piece, then you can kind of break this up and then look at it. Basically what I'm saying is that I think it's helpful to kind of break something up like this, where you are directly seeing, here is the results for young drivers that are on a phone, and for old drivers that are on a phone. And if we want to, we can look at young drivers not on a phone and old drivers not on a phone. This gives us a 2 square by 2 square factorial design. Whenever we plot this out, because as you can see, just this data right here is not super easy to interpret. Sure, if you scan around and look for it, you can see which group and which condition has the fastest brake times, which are going to be young drivers that are not on the phone, and that the slowest reaction time is going to be old drivers that are on the phone. Now, it's important to kind of think about the effect sizes here. So is it a meaningful difference? This is, for those that are as fast as possible, 780 milliseconds. For those in the slowest condition, a little over a second. So it's about a quarter of a second difference, But in terms of just looking at drivers that are on a phone, we have basically 912 to 1086, which isn't really that big of a difference. If we're looking at not on a phone, then we do see a kind of a, again, I guess it's not really a huge difference, is it? But whenever you compare both of them, that's whenever it's like, oh yeah, these two are pretty different whenever you think about it like that. Which is why it can be helpful to look at more than just one group and more than just two levels of an independent variable. By kind of looking at these more kind of complex factorial designs, it gives you a bigger picture, and we kind of see this interesting interaction in the data, that it looks like, does cell phone use matter? Sure, it does, but it really depends on what age the drivers are. So if we plot this data out using a line graph, which is probably the most effective way to do it like this, you see older drivers up here in this lighter blue line, and then younger drivers down here. So the lower values mean that they were able to brake a little bit faster than the older drivers. And we can see that this trend kind of carries through, right? So that it looks like these are parallel lines. That's going to come back up later. Ultimately, I'll spoil this a little bit for you. This means that there is essentially a main effect. If you see parallelism like this, that means there's a main effect. Alright, so this is from Strayer and Drew just a couple of years ago. They were looking at this, and so they call this main effect. The main effect is whenever you look at the condition and you see there's not a difference here and there's not a difference here, but there is, or sorry, I phrased that poorly, that there is a difference here and there is a difference here, but they're both differences. If we had something that looks like, so don't pay attention to this line right here. Let's say that it looked like this, then that would be an interaction, because we do have a difference here, but we don't have a difference here, and that would create an interaction, which we'll talk about in just a little bit. So a main effect is where you have parallel lines, where these lines don't intersect, and it looks like if you were to extrapolate this line, it doesn't look like they're going to eventually converge. So that would be a main effect. In other words, age matters when we're talking about brake times in driving, not necessarily just the presence of a phone. So here is another example, whether or not alcohol makes people aggressive. So in this particular, and again, this is also based on a real study, participants were given orange juice, or they were given orange juice and vodka, which I think is called a screwdriver, but I also don't really know because I'm not a very big drinker. So we got essentially a control condition, right, where we got the orange juice, which does not have alcohol, and then we have orange juice and vodka, which would not be the control condition. And then researchers are going to split those folks up into light and heavy groups, referring to their body type. So people who are a little bit lighter in terms of weight and people who are a little bit heavier in terms of weight, that's going to matter when we talk about how the body metabolizes alcohol. So that's how they split up these groups. So we're looking in terms of weight or body type, and then looking in terms of whether or not they got the orange juice or the orange juice and vodka. And the dependent variable that we're looking at here, what's being measured, is asking these people to quote-unquote punish a player in the game whenever they scored incorrect answers. This is a little bit of a, you can fast forward 30 seconds if you don't care about what the study was, but just to kind of explain what they were doing here, basically what they had these people in a group task. Now, these participants don't realize it, but there is no actual other person that they're playing with online in this group, and it's kind of like this memory game where like you're doing this task, and this person's fake group mate is going to get things wrong, which is ultimately going to cost this person points. And so the question is, at the end of the match, they could choose a level in which to shock or punish the player at the end of the game. And now as I'm saying this stuff out loud, it sounds very unethical, but again, they're not actually punishing or shocking anybody, they just think that they are. And so the researchers were kind of measuring what voltage of shock were people using to punish that second player. And this just kind of reiterates what I was saying here. So we got the two independent variables where we're talking about people that are light versus heavy, and also talking about people that drink alcohol and people that do not drink alcohol. So the half that just got the OJ, we would call that the placebo, right? To see whether or not the expectation of drinking alcohol, whether or not that has any effect on aggressiveness. So the dependent variable is how strong was the shock that participants measured. So here is the data. Now this is a little bit more complicated than the previous study. So I want to kind of slow down here to talk a little bit about what we're seeing here. So what you're seeing, let's focus just on this top figure right here. What we're looking at is these two groups, right? Folks with light body types versus heavy body types. And then we are looking at, in the orange, those that had orange juice and vodka, and then in the green we had the placebo group. So how do we interpret this? Basically what we're looking at here is it looks like for people that are light that there's not really too much of a difference in terms of the placebo group and the drunk group in terms of what level of intensity. We're talking about the difference between maybe a 6 versus a 5 in terms of the intensity rating of that shock. So not a huge difference, if any. Once we do statistics, we'll determine whether or not that's statistically significant or not. If we look at the heavy folks, though, we see there kind of is a difference, right? Or at least a larger difference. These lines are no longer parallel. So that means that it looks like there is a difference for heavy folks, that for these heavy men, I don't know, maybe they're like super ripped, like super strong, and they're ready to fight somebody now that they've had their OJ and vodka or whatever. But we see this kind of difference here between the placebo group and the drunk group. The difference between about 7 and a little bit below 5, which, now that sounds like kind of a pretty big difference. If we can plot this out a little bit differently here. If we look at the x-axis, this x-axis is the body type, and the lines are the conditions or the groups, whether or not they are drunk or placebo. We can kind of flip that so that the lines are the body types, and the x-axis is the whether or not there was alcohol present or not. And we see essentially the same thing, which makes sense. It's the same data, it's just kind of rearranged a slightly different way. Where we look at the placebo group, there is no difference, right? So there is not really any difference between people that have just the orange juice. It's the people that have orange juice and the vodka, which is the drunk group, that we do see there to be some differences. So that the people that are heavy are more likely to, or going to shock their participants with a heavier shock than those that are a little bit lighter. But even here, now whenever we plot it this way, that's the difference between about a 7 and about a, I don't know, like a 7 1/3 versus a 6. Which doesn't sound like all that much, right? But that's called an interaction. An interaction is whenever you do not have these kind of parallel effects. So we see there is no difference here, but there is a difference here for that. That's what an interaction is. So interaction, my advisor always put it this way, and I don't know, my grad advisor I should say, I don't know if this is helpful to think about it or not, but an interaction is a difference within the difference. What this means is that, yes, it does make a difference if people are drunk, but there's a difference within that difference, that it only matters if you're drunk, if you, for heavy men versus light men, the heavy men seem to be administering a heavier shock than the light individuals were. So that's why it is an interaction. So that is kind of how we interpret that. Anytime you see these kind of non-parallel figures, it's important to kind of slow down and kind of pick through it just to make sure you're interpreting it correctly. Because if you're like me and I see something like this, my first thought is like, oh, it looks like just people who are drunk are more likely to be aggressive than people who are not drunk. But sometimes it can be helpful to kind of think critically about how we present that data, because here it's very obvious that this is an interaction. But again, the important thing is whether or not these lines are parallel or whether or not they seem to be converging at some point. Alright, so here is one more example. The other example that I have for you is looking at, alcohol and aggression. But we're going to be doing things a little bit differently here. In this particular study, we didn't feel super good about just shocking or telling participants that they were shocking other people, even though they weren't actually shocking them. We felt a little bit bad about that. So we're going to determine whether or not alcohol is related to aggression. So whether or not alcohol is associated with aggression. So in this task, we want to know if whenever people think of alcohol, whether or not they are also thinking about aggressive behavior. So now we're talking about a cognitive psychology task, that's my domain. This is where we talk about the fun stuff, because we're talking about cognitive psych. We're talking about thoughts, and we're talking about associations that we make and things like that. So in this computer task, people are going to be asked to determine whether or not a string of letters is a word or if it is not a word. So if you're looking at these two words right here, you would say that PSYC is not a word and hallow is a word. So that seems pretty easy, right? And some of these words are going to be neutral, like the word hallow, and then some are going to be aggressive, like the word fury. So at this point, now we can start to see a little bit of, before I talk about experimental design, what is being recorded here? What we're recording here is going to be the reaction time of how quickly people respond whenever they see, or whenever they're responding to one of these words, whether it be a word or a non-word. Now, before that word is presented and they have to determine if it's a non-word or a word, we are going to show them an image. And that image is going to be presented very quickly. We call that priming. We're going to show it very quickly, we're going to take it away, and then see how they respond. And that photo can either be a plant or it can be an alcoholic drink. So just to kind of rewind and kind of come back to this question about whether or not alcohol is associated with aggression, this cognitive psychology task is essentially saying, if we show people an image of a alcoholic drink for a split second, is that going to make people respond more quickly whenever they see a word that is associated with something aggressive? If it is, then what we can infer from that is whenever people are thinking about alcohol, other words that are aggressive are also very easy to process and come to the top of mind. Words that are not associated with alcohol, non-biased words, we would expect would not be as fast in terms of responding if it was preceded by an image of alcohol. If it's a plant, we don't expect there to be any differences though. So in this case, we got different levels of the independent variable. We got neutral words and we have aggressive words. We got blanket, which would be a neutral word, and we have murder, which would be an aggressive word. And then we have whether or not a plant was presented or an alcoholic beverage was presented. The outcome variable, as I mentioned, is going to be how quickly they respond in this task. So here again, we have a 2x2 design, where we have the independent variable of phototype broken down into two separate conditions, or two separate levels, I should say. And then we have the word type, which is also broken down into two separate levels. So this would be a 2x2. So in this particular study from a couple of years ago, or a few years ago at this point, they found an interaction. So here, if we were to just look at this data and just look at these numbers in this table, it's really kind of hard to notice if there is anything important here, right? Whenever I see this, there's nothing that really catches my eye, which is exactly why it's important to oftentimes to plot this stuff out. To, even if you're looking at, I always tell I tell my stats students this, and I tell my research methods 2 students this too. Anytime you do a test, also make a figure for it, so that way if your data, if it says it's significant or whatever, you're at least looking at the plot of it to make sure that it's actually analyzing what you think that it's analyzing. So it's always helpful to plot out data whenever you can, even if it means like drawing it out rudimentary, like a very rudimentary drawing. So because when we plot it like this, we can see like for sure those lines are not parallel whatsoever. This is not a main effect, right? That there seems to be a huge difference whenever people are looking at the alcoholic photo, and a pretty big difference whenever people are looking at the plant photo. So let's break it down. What does this actually say? So for neutral words, we see that it takes longer to reply to neutral words whenever you just see a photo of alcohol. It's much easier to respond to a neutral word whenever you see a neutral image of a plant. But the opposite is true whenever we look at aggressive related words, so words like fury or murder or bludgeon. So whenever people just see alcohol right beforehand, they are pretty quick at responding to an aggressive word, and whenever they see a plant photo, it takes them a little bit longer to respond to those aggressive words. So which words come to mind first? Well, it depends. It depends on if there was a picture of alcohol or a picture of the plant. This is an example of an interaction. Does that make sense? I'm trying to think if I missed anything here. The thing that I'll say though is, these are not huge differences, right? And that's one of the things that comes up a lot in cognitive psychology, and one of the criticisms that people have about cognitive psychology is that if you look at the overall difference between whenever people are shown an alcoholic photo, we're looking at the difference between about 551 milliseconds versus about 562 milliseconds, which is about the difference of 10 milliseconds, which is not that much, right? So if you see a picture of alcohol, you're 10 milliseconds faster to think of an aggressive or respond to an aggressive word than to a neutral word. So whether or not that is meaningful, that's something that you have to decide, and usually people will calculate variables called the effect size to measure that kind of thing. Alright, so let's talk a little bit more. I think we're actually going to get done with this presentation much faster than I thought. So if we're looking at main effects versus interactions, one helpful thing, if you're just looking at the tables, can be looking at what's called the marginal means. The marginal mean is if you were to get the average across these two means. If you have a 2x2 matrix like this, like we see right here, then it can be helpful to get the average across. So if I average 5.09 and 4.72, then I get an average of 4.91, and then if I go across again, I get an average of 6.60. That is quite a difference, right? That seems to be quite a big difference between those two. If I'm to compare versus body weight, and I should say this is referring to the second study that we were talking about with alcohol and aggression. So if we're looking at body type, we're looking at light folks versus heavy folks, and if we were to average across, there's not really a huge difference here at all, right? 5.55 versus 5.96. So this is what I meant about a difference within the difference, that when we compare these two, it doesn't really seem like there's all that much of a difference, but when we compare these two, it seems like there is a difference, which means that excuse me, which means that there must be some kind of interaction going here where body type and alcohol are interacting so that one of these conditions and one of these groups has a higher value than the others. Here again, we can look for that interaction here, and this is why I think it's helpful to plot it out. And so just to reiterate, what we would say here is that here there is a main effect of sorry, I was just talking about this as if it had an interaction. But here what I mean is that there is a main effect here because we see that there is a difference between these two. We see there's probably not a main effect here between these two. Once we plot it out, we get a better feel for that and you know, to see what that looks like. And this can tell us about whether or not there is interaction. If we were to go back and actually look at that data though, then yes, you can see there is an interaction. But if you're just relying on the table, sometimes that works. But sometimes it doesn't always work. Like for example, if you're looking at this data, if you're looking at the marginal means here, we're looking at the difference between 555 versus 557 versus 556 versus 555. So not really any main effects, right? So we don't have any main effect. But we do have an interaction because when we plot it out like this, we see that they are quite different. All right, okay. Then one of the final things that I want to talk about is yeah, like how should we plot this stuff out? So this comes from, I'm just gonna code this as number 3 just to remind ourselves where this data is coming from, because we talked about 3 separate studies. So in this case, and you already saw this this data right here, this, you know, you can plot it out like this, or you can kind of plot it out like this. Either way, what you are doing is you are splitting up the different levels of the independent variable or groups, whichever you use, so that you can look for interactions, you can examine for it. Here we can see there's an interaction because these lines are not parallel. If you decide to use a bar graph, which is also a very popular option, the thing to look at for here is going to be, well, I'm going to tell you a trick, okay? The textbook isn't going to tell you this trick. I don't know if Dr. Camilleri or Dr. Bressler or whoever else is going to tell you this trick. This is a trick that I learned whenever I took research methods, and I've never seen it printed in a textbook. It's never failed me though, so I'm going to pass this secret on to you. So if you get a bar graph like this, it can be a little bit tricky to determine whether or not you have a main effect or whether or not you have an interaction. Here is one really easy way to do that with bar graphs. It's easier than you think. I want you to take this bar graph, I want you to take a pen, and I want you to make a line. So I'm going to be going from, for neutral words, I'm going to be going from the alcoholic over to, ooh, that's a curve, that's not a line. 1 second. There we go. And then I'm going to do the same thing for the aggressive related words. A line there. Alright, and so when we do that, we see that these lines are not parallel. We see that these lines intersect, that they converge at some point, which means that it is an interaction. And I know what you're thinking. You're thinking, wait a second, Professor Daniel, you said that you'd be able to identify that using bar graphs, but clearly what you've done is you just created a line graph using a bar graph. And I'm going to say, yes, I did, and you're not going to be able to stop me from doing that because I'm going to do it on this figure right here too. So this figure right here, we know that it's going to be a main effect, right? Because we talked about this already. We'll know just by looking at this data that these lines do not seem to be converging, right? That these lines do seem to be parallel for the most part, so it's a main effect, probably not an interaction. If we look at this in terms of the bar graph, I'm going to do the same thing where I'm going to connect these bars using a line like that. I'm going to do the same thing for these bars like that, and that gives me two lines that don't intersect, so we can say, okay, it looks like this must be a difference. But the difference here is because of the age of the driver, not necessarily whether they are on a cell phone or not on a cell phone. All right. I hope that makes sense. And I know, I'm sorry if you're watching this, it's hard to see over here, this top right one, because my image is kind of clogging that up, and I apologize for that. But you got the lecture slides you can open up, and you'll see exactly what I mean if you can't see it. All right, so if you want more independent variables, you can. Go for it. Go wild. Have as many independent variables if you want, as many as you want. But here's the downside. The more independent variables you have, the bigger the headache you're going to have is going to be. Like, is going to increase the level of migraine that you have, the more independent variables you have. And trust me, I'm telling you from experience about this. But it's okay. If you are cool with that, that's fine. But if you decide to use more independent variables, it's much harder to draw conclusions whenever you have more and more independent variables, because it can create more complicated interactions. So let's go with one final example here, where we're going to be looking at the cell phone and driving example, but instead of just looking at age and instead of just looking at cell phone, we're going to be adding in another condition. We're going to be adding in the condition of hands-free driving condition. So they have a cell phone, but it comes out of their stereo. You know, it's not like they don't have to have it, you know, close to their head, which I think is illegal, at least in Massachusetts anyways. So here we can put this into a factorial table like this. And so here, if I were to ask you on a quiz, you know, what kind of factorial design is this? You would say, well, that is clearly a, sorry, that's hard to read. That is clearly a 3x2 design, because we have 1, 2, 3 levels of one condition, and then we have 1, 2 levels of another condition. And that makes it factorial design because there's more than one independent variable. And it honestly doesn't matter if it's 3x2 or 2x3. It shouldn't really matter, however you phrase that. The number, which number comes, doesn't matter too much. Usually, researchers like to start out with the largest number. So if you have like 2x8, usually it'll be referred to like an 8x2. But it, you know, that's a really nitpicky thing to think about. So if we're adding in this condition again, we're going to rerun this experiment. Now let's take a look at what we see here. Oh, this is kind of complex, right? Are these lines parallel? I don't think that they're parallel, right? It seems like that they are kind of parallel from here to here, but they're parallel from here to here. But if we look at from here to here and here to here, maybe they're not so parallel if we look at the whole picture, right? So if we're looking at this, we can see that there's some kind of interaction, right? That basically what we see is, okay, there's a main effect here of age, right? There's a main effect of age, there's a main effect of age. But whether or not we decide about the hands-free condition, whether or not that is going to contribute to this, about it, you know, being an interaction, we'd have to run tests on. So if we want to, though, we can go beyond this, and we can add even more conditions. We don't have to just have these three pieces where we have these three conditions of like no cell phone, and hands-free. We can also add in whether or not it's heavy traffic versus light traffic. We can also add in if it's light outside or dark outside. We can also add in if you are also trying to drink a coffee or not. You know, the sky's the limit when it comes to those things. But like I said, it just gets a little bit more complicated. The way to interpret this, though, whenever you do get these kinds of things, like for this image right here, one way that can be helpful to break this out is by creating separate plots. So now what I'm doing is I'm creating one plot that's just for light traffic and one plot for heavy traffic. And then again, you can kind of see these lines just like before, that we have these lines representing age, and then we have these two x-axes representing if it's hands-free cell phone or if it's a no cell phone. So we're kicking out the cell phone condition. We just want to compare these and whether or not, and how people do in light traffic versus heavy traffic. So if I were to ask you, is there an interaction here? I hope you would say yes, yes there is. And if I say Where is the interaction? You would say that the interaction happens in light traffic. So how do I interpret this? Because there's so much data here, how do I possibly make sense about this? Here's what I would do. If we're looking at the big picture, we see that over here we got a main effect. Over here we have an interaction. How do we know? Because over here we have parallel lines. Over here we don't have parallel lines. So what we can say is like, hey, we know that age makes a difference, but does cell phone use or hands-free cell phone use matter? It doesn't seem to matter whenever you are in heavy traffic. When you're in heavy traffic, it seems like no matter what, you're going to be, whether or not you have a cell phone or not, it doesn't seem to make too much of a difference. What makes more of a difference is the age of the individual in heavy traffic. If we look at light traffic, that's no longer the case, right? In light traffic, things are a little bit more complicated, because in light traffic, whenever people have a hands-free set, we see a difference here. We see a difference between older drivers up top and younger drivers up here, meaning that older drivers take a little bit longer to stop compared to younger drivers. However, when we're looking at no cell phone use, we see that there isn't a difference. So in light traffic, it doesn't matter if the person is old or young if there is no cell phone. That is how to interpret that. There's a lot of data there. That's kind of hard to interpret, right? Because it's very specific. That if somebody were to ask, looking at this data, does cell phone use matter? What you would say is, well, it's complicated, because it does not, cell phone use does not matter whenever we're considering people in heavy traffic. Because for people in heavy traffic, their results are more influenced by the age of the driver versus whether they have hands-free or no cell phone. But if we were talking about in light traffic, cell phones do matter, because if you are younger, it's okay to use hands-free, because that's not going to change compared to if they have no headset. It's just that the older drivers out there have a slight delay for the hands-free cell phone, but no delay when there's no cell phone. Wow, that's a lot to talk about, right? And we wonder why these research articles that we read are so long, is because in order to be so precise, it can take a long time to explain things. And if we want to go mad, we can look at all sorts of. So this figure right here is adding back in the cell phone condition. So we're looking at folks with no cell phones versus folks on cell phones in light and heavy traffic. We're looking at old drivers versus young drivers, and then we're looking at the effects of light traffic. Basically, we can look at this in all sorts of manners of ways, and I would look at these and say these all seem like they're kind of main effects. The only one I'd be kind of concerned about is maybe this one. That one I might want to run a test on to make sure it's not an interaction. Yeah, so if you were to ask, is there an interaction here? We'd say no. If you were to ask, is there an interaction here? You'd say yes. How do you know? Because these lines over here are not parallel. And that's pretty much it. Wow, we got through that much fast. We got through that about twice as fast as what I thought we would. I thought that would take about an hour to get through, and it took us about 37 minutes, which is awesome. Okay, so here's the thing. I promised you something special at the end of this, and previously I would show you pictures. I would go grab a dog or something like that. But I wanted to try something special because I want to see if this works. This is the very first time I've ever done this. So what I want to do, if you send me a meme or a funny picture related to research methods or research, let's just say research. If you send me a picture or a meme or something that makes me laugh that's related to this class, I'll give you 2 points on the final exam. Only one admission per person, though. You can't send me like 5 things and get 10 points. I'll let you do it once. But yeah, just email it to me. You can email it to me at tdaniel@westfield.ma.edu. So I look forward to that, and I hope that is just as special as a video of my dog or whatever. Thanks so much for tuning in. If you have any questions, feel free to email me and let me know. Otherwise, I will see you later. Bye-bye.